Okay, so today we're going to be evaluating rational exponents again. Just thought that I'd keep that nice little t-shirt picture in the corner. And rational exponents, remember, are exponents that have fractions. So rational numbers are numbers that are basically fractions or decimals. So this is question A is a review of what we did yesterday. So when you have an exponent that is a decimal, a fraction, what you want to do is create a root. So I'm going to keep the bracket inside the root because it's there in the question. I'm going to take the denominator, put it where the index is, and put all this to the power of 4. At this point, I'm going to calculate the third root of negative 27. And if you remember what that means, it means it's a number that when multiplied 3 times, it gives you negative 27. So you can just go ahead and type that into your calculator. Okay, so the third root of negative 27, don't forget the brackets if you're typing this into your calculator. So that gives me negative 3 to the power 4. From there, you can just type it in, negative 3 to the power of 4, and it gives you 81, because negative 3 multiplied 4 times is equal to 81. Moving on to question B, we haven't done a question that deals with decimals, but we can convert that decimal into a fraction. So negative 0.75 is actually negative 3 over 4. So since it creates a negative fraction, negative fractions make you create negative exponents, make you create fractions. So we're going to create that fraction, and we're going to do the reciprocal of 16 over 1, which is 1 over 16, and then we're going to make the exponent positive. So by doing this, we create an exponent that is a rational number, so that it's a fraction. So when we have an exponent that's a fraction, you want to make a root. Take the denominator, put it down here, and make your exponent. Your numerator goes on the outside. In order to calculate this, you want to split up your root for the numerator and the denominator. So I'm just going to continue over here. So that's the fourth root of 1 divided by the fourth root of 16, but all that will be to the power of 3. Any root of 1 will be equal to 1. And the fourth root of 16, if you do that in your calculator, you will get 2. And all that to the power of 3. So it looks really complicated until you actually start doing it. And 1 over 2 to the power of 3 means 1 over 2 times 1 over 2 times 1 over 2. You don't have to write this step, but I just want you to understand where the 1 over 8 comes from. Okay, moving on to question C. At this point, we have 3 bases of 8, except one of them is a radical, and the other 2 are exponents with fractions. So what we want to do here is we want to convert the one that's a radical into an exponent with a fraction. So I'm going to keep the ones that are fractions, but I'm going to have to change the one that is not a fraction. Okay? So to change that, you have to understand what number is the index and what number you have as an exponent. And they're both kind of invisible. So the number that's the index, right over here, is a 2. Remember that it's not a 1. When you have a root, it's actually the square root. So remember to put that where the denominator is. So I'm going to put 8 to the power of something over 2. Now for the exponent part, that exponent is also invisible, and when we have an invisible exponent, it's always equal to 1. So moving on, going back to our exponent rules from Wednesday, you're going to have to keep the same base and add your exponents for the top. But when you're dividing the same base, you want to subtract your exponents. Okay? So this becomes just a fraction problem, which you all know how to do by getting a common denominator. We're going to multiply the top and bottom by 3 for the second fraction, and multiply the top and the bottom by 2 for the third fraction. So this becomes 8 to the power of 5 over 6 plus 3 over 6 minus 10 over 6. When we add or subtract fractions, we just add the top. So 5 plus 3 is 8. 8 minus 10 is negative 2. Don't forget to reduce. Extremely important to reduce. This gives us negative 1 over 3 if we divide both the top and the bottom by 2. Now you can't leave your answer like this. 1, because there's a negative exponent, and 2, because there's a rational exponent. So there's a fraction there. So we're just going to simplify this by creating a fraction to get rid of the negative exponent. We're going to do the reciprocal and turn this exponent positive. Once we're done doing that, we're going to distribute that 1 over 3 to each, or we're going to make a root of 1 over 8. We're going to put the 3 where the denominator inside where the index is. And at this point, we're going to do the third root of 1, but we're also going to do the third root of 8. Any root of 1 is equal to 1, and the third root of 8 is equal to 2. You can double check that if you want on your calculator, but I know that 2 times 2 is 4, and 4 times 2 is 8. Okay, now, example 2 is a pretty complicated one. So in order to start this, remember what I said, that when you have variables and you have numbers, to split them all up. So what we're going to do at this point is we're going to take this 27 and we're going to put it to the power of 1 over 3. We're also going to take this a to the power of negative 3 and put that to the power of 1 over 3. Take the b to the power of 12 and make that to the power of 1 over 3. So all I did here was I distributed in order to split them all up. So we're going to do the same thing at the bottom for the denominator. 16 to the power of 1 over 2. You could put that in brackets as well if you want to. Okay, so that's what this is looking like. Again, it might be helpful to rewind this video, go back to the other video, and remember which part we did this for. So we'll start by doing the numbers. Okay, so we'll start by doing 27 to the power of 1 over 3 and 16 to the power of 1 over 2. So 27 to the power of 1 over 3. Our exponent is a fraction, which means we need to create a root. It's not necessarily the square root, it's actually the third root because the denominator goes where the index is. Okay. All of this is going to be over the same idea, but 16, and the root will have an index of 2 since the denominator is 2. Now both are to the power of 1 because the numerators are equal to 1. Now that we're done that, we're going to go ahead and do power of a power, okay, for each one of these power of a powers. So be careful when you're multiplying. You just multiply the numerators. Remember that your denominators are 1. So negative 3 over 1 times 1 over 3 is a to the power of negative 3 over 3. Oh, I put that in the wrong spot. We need to make sure that that's in the numerator, because the original one is in the numerator. 12 times 1 over 3 is b to the power of 12 over 3. I'm going to go ahead and do the a in the denominator. This will be a to the power of negative 8 over 2 and b to the power of 12 over 2. So as long as you're not multiplying the numerator by the denominator, then you're safe. Those are basic rules that you should have hopefully by now. So the third root of 27 to the power of 1. Well, to the power of 1 is pretty much useless. Anything to the power of 1 is just the anything. So I can go ahead, use my calculator, and figure out what the third root of 27 is. And hopefully you're getting more comfortable with these third roots. I know that the third root of 27 should be equal to 3. Third root of 27 is definitely equal to 3. So I put a 3 in a bracket up here. I'm going to simplify my exponents. So I'm going to go ahead and simplify this one, that one, that one, and that one. Okay. So a to the power of negative 3 over 3 is going to turn in to a to the power of negative 1. We're going to have b to the power of 12 over 3. That's going to change into b to the power of 4, since 12 divided by 3 is 4. I'll just continue simplifying the exponents, and then we'll go back to the square root of 16. So this becomes a to the power of negative 4, and we have b to the power of 6. To calculate this part here, we know again anything to the power of 1 is just the anything. And this is the second root of 16, which the 2 doesn't really need to be there. It's really just the square root of 16, which is 4. So, moving on, we have 3a to the power of negative 1, b to the power of 4, and 4a to the power of negative 4, b to the power of 6. We have some exponent rules to follow. We're going to keep the 3 over 4, keep the same base for a, and subtract your exponents. Since we're dividing the same base for a, we're going to keep the same base and subtract the exponents. Same thing for b. We're going to keep the base of b and subtract our exponents. So now we're left with 3 over 4 times a to the power of negative 1 plus 4, which is a to the power of 3, and b to the power of negative 2. Now, since you have a negative exponent, you have to simplify that. Don't forget that you have to simplify that. And that basically becomes a fraction. But in order to not complicate this, because you already have a fraction, keep your positive exponents at the top and keep your negative exponents at the bottom, but make sure that you make it a positive once you put it in the denominator. This one it's pretty tough, but you're going to be trying on page 79, number 14, 16, and 17. And then there's another worksheet for you to work on. So I want you to find the errors in the worksheet and work on these questions here that are given, number 14, 16, and 17.